Okay, this is the homework help video for Honors Math 3, Unit 9, Worksheet 9, and this is question number 1. So for question number 1, the directions just ask you to simplify. So this requires you to know which formula to work with. So I'm just looking for, so I'm going to pull the formula sheet up here in just a second. So something that looks kind of like this, right? So we have a fraction, and then we're subtracting, and there's a cosine on the right. So when I look here, I see that in my power reducing formulas, I have the fractions that are like this, and then there's a subtraction with a cosine on the right. So this is the formula I'm going to be working with. So I'm going to go ahead and just write that down right next to it. So the formula that I have is sine squared theta, and then equals 1 minus cosine 2 theta divided by 2. Okay, so that's the formula that we're looking at. So for this here, okay, so then what I want to take a look at in terms of how are they similar, how are they different? So in this case, I'm given the right side. So I have the right side, and so I want to convert it to the left side. So to be able to do that, I need to do a little bit of adjusting. So the first thing I'm going to do is I want to pull that 3 out. So I'm going to factor the 3 out. Okay, and so really then that 3 is really for that whole thing. So then now when I look at this, they are matching, right? So then I know this is my 2 theta right here. So this is the 2 theta. And so again, I'm given the right side and I want to convert it to the left. So that 3 is going to stay here. I know it's going to be a sine squared. And so now I just need to figure out what do I do with that angle. So I know when I look here that this angle is twice as big as that angle, right? So twice as big as that angle. So if this is twice as big, so this is 26 degrees, then I want to take half of 26. So I'm going to take that angle right here, and I'm going to take half of 26. Oops, and then that would be 13 degrees. So then this would be 3 sine squared, 13 degrees. And then that's it. Okay. All right, let's take a look at question number 7. So same thing again. So I'm looking for formulas that look like that. So I have a 2 here, and then I have a 5 cosine and a negative 5. So when I'm looking at the formulas, none of them quite line up, right? It's pretty darn close to the sine squared again, except for it's upside down, and then there's that negative problem. Okay, so that's the one I'm going to go with, right? So it's pretty close to that. Let me get a different pen out here. Hold on, sorry. So again, I'm going to use that same formula. So let me write that down again. So this one I'm going to have a lot of adjusting I'm going to have to do, but it's pretty darn close, right? Pretty close. So I'm going to go ahead and pull out that 5 because I know that that can't be there. And when I factor the 5 out, I don't take it out of the angle, right? The angle is not going to change. And so really then I have 1/5. And then I see that this is backwards compared to this, and it's upside down. So I'm going to fix the backwards part first. So I'm going to go ahead and take out a negative. So I'm going to put a negative out front here. And then when I factor out that negative, this will turn positive and this will turn negative. So it'll be 1 minus cosine of 140. And so this again, it's upside down, right? So upside down, that means it's going to be the reciprocal. So the reciprocal of this. So I still have negative 1/5, that doesn't change. But then it's going to be 1 over sine squared. And then again, when I look at the formula, this side right here is double this side. So this side is double. So that means I want to take half of the 140. And so then that would be 70 degrees. And then I'm going to fix that just a little bit here, right? So I'm going to just do that as the reciprocal. So 1 over sine squared is the same as cosecant squared, and then 70 degrees. And that's the end of that one. Okay. All right, let's take a look at another one. So that was 1 and 7 on worksheet 9. And then let's do number 12. That'd be flipped around here. Okay, so the directions for number 12 is they tell us that the cosine ratio is 12/13 and then theta is not acute. So then I know that cosine is positive in the right side. So it's positive over here because it's the x value. And if it's not acute, then that means it's not in quadrant 1 but in quadrant 4. So let's go ahead and we're going to draw a triangle in quadrant 4, mark my central angle, which is theta. And so cosine is adjacent over hypotenuse. So the adjacent side is 12 and the hypotenuse is 13. And then from there, I would do Pythagorean theorem to find the missing side, or if I know my triples, I know it's 5. And then going down is negative. So if I didn't know that, I would do like a squared plus b squared equals c squared, and then so on, and get a. All right, so I have my triangle, and so then now for number 12, for part A, they want me to find the sine of 2 theta. So again, I need to know my expansions, right? I need to know all of them. So if these look like I just got them out of thin air, it's because I have them in front of me and I'm just looking on my sheet, or I have them memorized. So the expansion formula for sine of 2 theta is 2 sine cosine. So now I just need to do some substitutions. So I'm looking over here at my triangle and I want to do the sine ratio. So sine is opposite over hypotenuse, so opposite over hypotenuse. And then cosine was given, but I can also do it off the triangle, adjacent over hypotenuse. And then just put that over 1 and then multiply straight across. So I have 2 times -5 times 12. And then 1 times 13 times 13. And so there is my sine of 2 theta ratio. So that means when I double the angle, sine became negative. And I know sine is negative in quadrants 3 or 4. So then for part B, they want me to find what quadrant 2 theta is in, and I have to justify. So then that means I either need to do cosine or tangent. We typically tend to do cosine, so I'm going to do cosine. And I'm going to do the expansion for that, so that would be cosine squared theta minus sine squared theta. And then I do the same thing again, so I'm going to use the triangle over here. So I want to do cosine ratio, so adjacent over hypotenuse, but squared. And then the sine ratio, opposite over hypotenuse, but squared. Then I'm going to go ahead and square that out, so that will give me 144 over 169 minus 25 over 169. And then I want to subtract that. Let me do that off to the side here. So 119. And so that's cosine ratio, so cosine's ratio, which is positive. And I know I have it narrowed down to 3 or 4. So then that means it has to be in quadrant 4, and that's because that is where cosine is positive. So therefore we are in quadrant 4. Okay. All right, and then let's take a look at part C. So for 12C, they want us to figure out what quadrant theta over 2 is in. So I'll do that over here. So I know that theta is in this quadrant here. So theta is somewhere between 3 pi over 2 and 2 pi. So if I want to figure out theta over 2, then I'm going to multiply that inequality by 1/2 because I want half of the angle. And so then I will distribute 1/2 into all of those pieces. So that will give me 3 pi over 4, theta over 2, and pi. And then from there, I know that that is, so I have to be smaller than pi, so but bigger than 3 pi over 4. So that's somewhere in quadrant 2. So therefore, theta over 2 is in quadrant 2. And then 12D asked me to find sine of theta over 2. So again, I'm just using my formulas here, so if you don't know them, you need to, look on your sheet. And so for that formula, it's plus or minus 1 minus cosine theta over 2. So first I want to decide, well, is it plus or is it minus, because I can't have them both. And so I know that I am in quadrant 2 for theta over 2 according to part C. And sine in quadrant 2 is positive, so I'm going to be using the positive version. And then cosine of theta, so again I'm just looking back up here, adjacent over hypotenuse, and then divided by 2. And then I just have to simplify that fraction. So that would be 13 over 13 minus 12 over 13 divided by 2. So that would be 1 over 13, and then instead of dividing by 2, I'm going to multiply by 1/2. So that would be just 1 over 26, about a 6 there, or 1 over root 26. And that's that, okay? All right, and let's look at one more off of this worksheet 9, so one more. Okay, last one. So for 14, we want to solve for theta. So I want to use my expansion formulas for each of these. So I'm going to expand this guy out. And then for cosine of 2 theta, I have a few of them here, right, that I can expand it to. Let me show you real quick. So I actually have these 3 right here I can use, but I know that I want to cancel, what do I want to cancel? I want to cancel a 1. So that means I'm probably going to use one of these here, right? So I'm going to use one of those 2. So let me write that down off to the side. So I want to be able to use one of those, and again, I'm trying to cancel the 1. And so I want it to eventually be a positive one over here, and I have that negative. So if I used the bottom one, it would turn into -1, which I don't want. So I'm going to end up using this one here. And so it's going to end up grouping because I have that minus. And then I'm going to need to distribute. And then from there, I'm going to subtract 1 from both sides. And then I'm going to factor, so zero product property. So I can take a 2 out and a cosine. And then I'll split it and use zero product property. So I'm going to set this one equal to 0 and this one equal to 0. So divide by 2. And then I know cosine is the x, so I want to know where x is 0, and that's going to be here and also down here. So it's going to be on a quadrantal. So that would be at pi over 2. And down here at 3 pi over 2. And then this one over here, this one's a little bit tricky, right? So we can't factor this anymore. So I have to like get a little creative in how I'm thinking about this. So I know that the difference between two things, for them to be equal to 0, they have to equal each other. So for example, if this was 5, this would have to be 5 as well. Otherwise the difference wouldn't be 0. So what I'm really looking for is where does sine equal cosine, right? That's what I'm searching for. So for example, I'm just going to throw out the unit circle quadrant 1 here just to kind of explain that a little better. So if I look at this ordered pair, this would be 1, this would be 0. X, y, sine, cosine. So is sine and cosine equal to each other here? And they're not. So what if I look at 30 degrees? Is that where sine and cosine are equal? And it's not. But what if I look at 45 degrees? And so that is where they are equal. So where does sine equal cosine? And that would be at the 45 degrees. But I want to be in radians, so that would be pi over 4. So that's where they're both positive, right, and equal. So where are they both negative and equal? And that would be down here in quadrant 3. And so then I would have to find the quadrant 3 answer as well. And so that would be 5 pi over 4. So that would be that one. And that's it for this video.